I'm glad to see you all, because most of the participants I know personally, and it's always a pleasure for such communication. Today we have some presentation, of course, about fertilizers market, about some other new knowledge and experience which we would like to share with you. But feel free to ask questions, feel free to communicate after each section, or when you feel, then you can join. So because if it can be more interactive, it's even more valuable. So actually, almost 1 year ago, on the 3rd February last year, we were talking on very similar topic about the use of and perspectives of biofertilizers. The situation was also some kind of pre-crisis, and prices of fertilizers were already on quite a high level, but nobody could expect what was happening after. So after these actions, after this what happened, it also influenced agricultural market a lot, not only with fertilizers, but also with prices of commodities, with logistics, with actually normal way of business, which was doing before. So now we gathered some information from the market, which we would like to introduce to you. So actually, what topics we will cover today? So we will talk a bit about the situation on the fertilizer markets. We will also introduce you some methods of optimization of use of fertilizers, and we will show you our real experience in it in different countries of Europe, and with different methods, different products, which, because we understand that for each region there could be some specific tools, specific technologies which can be more convenient to this or that farmers. So mainly most of the participants know who we are, but for those who join us first time, I will just in a few words remind who is BTU Center. So BTU Center is a Ukrainian producer of microbial products for agriculture. We are 24 years old this year. We have two business directions. So the main is products for agriculture, but also we produce some products for human health and for bioremediation and oil production intensification. So talking about agriculture, we have more than 60 products. Most of them are certified for organic agriculture. Already we have near 10 products registered in different countries of the EU. Those which are registered are FIBL listed or organic certified as well. We are present also in a segment of home and garden. So we propose our products for people to use at home as well. We gather more than 400 people, and from that a big part is practitioners, technicians, and scientists who do a lot of studies with the product. We do thousands of studies to get a confidence in our products and to bring our confidence to our partners, to the farmers, because we do tests in different conditions, different soil types, different modification, and etc. So some of that thousands we will not show you all today, don't be afraid, but a few of them we will show. And also we have a brand of Healthy Land, which is adopted to different languages, which is somewhere reflects our philosophy about care of environment, but with a focus on the rich yields as well. So coming closer to the topic, actually some of the milestones remains from the last year, like people still are, population is growing, more food is needed, and soil degrade because of intensive use of agrotechnologies, and we can see that there is no so big potential to increase arable land in the world, and some kind of a peak of the technologies of the yield is also reached. So we don't have a big perspective to increase yield with new hybrids or like with something very novel. So we need to optimize, we need to care about the soil properties, and yeah, then we can grow organically. I mean, in terms of population on the world, in the world, and in terms of feeding that population. So because of that, there are such initiatives like a Green Deal in Europe to optimize use of fertilizers, to use less toxic pesticides, and to develop organic agriculture. And in all that directions, we see a like tremendous perspective for biologicals. It's one of the key instruments in these targets. And of course, a new milestone which we see this year is geopolitical instability in the world. Of course, Ukraine is now in focus with Russian aggression, but also we have some, we see some instability in other regions. So it is a new reality to which also agrarians should be ready, because it influences supply chains of fertilizers, it influences the chains of commodities trading, and rotation schemes, new focuses. For example, because of this geopolitical situation and fertilizer situation in 2023 in Ukraine and in Europe, I think we expect increase of land under legumes like soybeans. So it's all should be taken into account. So if we talk about the situation in the market of fertilizers, one moment. Yeah, so you can see that it was more or less stable during like 5-6 years, and then after COVID, we have some beginning of crisis with growth of main types of fertilizers, but of course with beginning of 2022, there was a tremendous jump in prices, and fortunately, in second part of 2022 and in the starting of this year, we see some kind of stabilization. Of course, it's not that stabilization which could be beneficial to farmers, I mean, in terms of coming back to prices, optimal prices or lower prices, but it's already lower than it was on the peak season last year. So we see that still a big part of fertilizers are exported from region of East Europe, and it's somewhere a risk also, because it is impossible to substitute that very quickly. And that is why there could be still some, no, it cannot stabilize to how it was before the situation, geopolitical understanding normalize. So what else we can say? Because of the situation on energy price with gas prices, a lot of fertilizer producers reduce their production, not capacities, but a lot of their production capacities, and that is why also less fertilizers are present on the market, maybe some higher prices because of that. And of course, there are some regional restrictions, because when we had an unstable situation in the beginning of the year, a lot of countries introduced some restrictions, like China, as I remember in Turkey, even in Ukraine, also there are some restrictions for export of some particular kinds of fertilizers. So if we talk about the trends which are expected this year, so there is some kind of trend of prices stabilization. There is still some, let's say, not overproduction, but decrease in production of fertilizers, of nitrogen fertilizers in Europe. Logistics cost increase, it's also very important, not only for fertilizers, but for the industry. There are some political factors like sanctions and restrictions, especially for some bloc of countries in the East, which you probably all know. And of course, some restrictions in some countries like China, who also are quite a big exporter of fertilizers. There are some legislative limitations. For example, anhydrous ammonia is not allowed in Europe. Actually, it's not something good thing for soil, but still it is still allowed in some of countries to apply. There are some restrictions for nitrogen fertilizers in some other European countries like Germany and France. For example, in Germany, you cannot use nitrogen fertilizer in autumn. There are some also restrictions for export of commodities from countries who do not support some of European initiatives. So like Green Deal is not just only about European Union, but it influences all the region at least. So it should be taken into account. There are some ecological trends, like again, Green Deal and other supporting initiatives. This year, we see also a new strategy of EU about soil care. So it's also give some recommendations to EU countries. So there will be more opportunities somewhere to projects in soil improvement. And of course, farmers and industry want to reduce environmental pollution of agriculture. And I must say, because just last week we were meeting with some of farmers in Slovakia, and it was very pleasant to hear that some farmers start the topic, and owners of the farms initiate projects of like regenerative agriculture. And it's very important that it's not only being put by legislation to farmers, but farmers feel some kind of, not a need, but some kind of feeling that they need to care about land and environment. Besides that, there are some technological trends. For example, new technologies come into the market, they become more popular, they become more proven, such as biofertilizers, which we will talk today, but also precision farming and nitrogen inhibitors, complex fertilizers, special formulations of that, like special coating and etc. Yeah, so also we see some kind of through the history we see that there is some, again, a limit of increase of yield by use more and more fertilizers, and it's logical. And even this year in few regions of Europe, like in Czech, in Belgium, UK, in Germany, we have seen some examples on research stations when we had a trial with complete dosage of fertilizer and decreased dosage of fertilizer show better yield than a complete scheme. It's something out of logic somewhere, but it gives us another stimul that we are on the right way, that intensive technologies can be integrated with biologicals for more efficient use of sources. And with that, integrated pest management practices are implemented, and as well, also in some scientific article from the last months, I have seen a new, for me, definition of integrated soil fertility management, which I see also a very perspective to develop, like IPM, but about optimization of fertilization schemes and so on. So we will talk today a little bit about biofertilizers. So I will just want to remind you what is that. So biofertilizers are one of the biological products, which also include biostimulants and biocontrol. But biofertilizers are focused on nutrients solubilization, mobilization, or nitrogen fixation, or micronutrients solubilization. So those are the things which helps to make soil function better, and how to get more nutrients from existing sources, or uses nutrients more efficiently. So the main category in this are microbials, which we will talk to today. And in terms of the market, it's still a smallest part of the biological product market, but it's quite actively growing. And of course, if we compare it with the size of the all fertilizers market, is just 1%, but I personally believe that it will grow maybe to 5–10% in recent 10 years for sure, because we see a big perspective in them from our experience. So if we look on the main stimulus of the use of biofertilizers, it's again, we talked about them last year, and there are some more or less constant things like accumulation of insolubles, nutrients, ecological impact of fertilizers use, and these initiatives. It will work in any conditions, but of course in this year, last year was actual food crisis due to some geopolitical issues in the region, and decisions because of this, I mean, in terms of sanctions, and of course because of supply of energy resources. But more or less, again, you can see that with fertilizer index, fertilizers are still quite expensive, and even with some stabilization, it's not expected to reach how to say the degree which was before the crisis. So here we can see some of the advantages of use of biological fertilizers. They are ecological, they are efficient, they are organic in most of cases, and very often they have positive after effect on the soil and on next crops, and in general they have some positive influence on the soil. So what we will talk about today is a set of biofertilizers from BTU Center. That is a PK mobilizer ground fix. It's one of the most demanding of products during recent years. We again are quite confident in this product because we have more than 400 trials in different conditions on different crops with it, applied mainly technologies. And already we have plenty of trials to decrease fertilizer dosages or to monitor the increase of availability of PK, some of which we will show you. And also we see that it is possible to combine this product together with some intonic mixes with mineral fertilizers, with organic fertilizers, with herbicides. Also, we will show some of the examples today. So second direction we will talk today is nitrogen fixation. Again, we have some already real examples of substitution of nitrogen in different countries of Europe, and results from this product are quite stable and sustainable. And interesting is that we studied this product also to improve drought tolerance of plants during two years already, and we see that among our line of biostimulants, Azoto provides one of the best results. So it's another important direction because of climate change and very dry last few years. And the third direction would be about mycorrhiza. Mycorrhiza is in the air. Actually, it's in the soil, but it's in the air in terms of talking about it last years. So it's fungi applied on the seeds to develop symbiosis between with roots to enhance uptake of nutrients and water. But again, from practical part of this, we see a very great economic effect of it on corn, sunflower, where we get in average more than 100 euro per hectare profitability. And we will tell about that again a little bit more. So now I will give a word to Alexander to introduce a little in detail the products we talk about.
Hello, everyone. Can you hear me well?
Yes, we hear you.
Okay. So, yes, dear colleagues and new listeners, my name is Alexander Runsevich. I'm one of the agronomists at the International Department of BTU Center Company. So I'm here today to talk to you about some practical cases, as said Dmitro, about use of biological products, the ability to substitute fertilizers, simultaneous application, and other cases. So we will start with the product AzotoHelp, which is based on the nitrogen-fixing bacteria Azotobacter cryococcum. And this product is mainly used for as a monoproduct for nitrogen fixation, for seed treatment, soil application, and foliar feeding as well. So this product based only on one bacteria with some additional components like vitamins, amino acids, and other. I'm sorry, Dmitry, can you?
Yeah, sorry.
Thank you. So about how to check the product work, we mainly focus on the seed germination. We can see some visual effect of by stimulation of the root development and vegetation mass. And also we can say that the product when we apply it in the soil can enrich it with nitrogen up to 60 kilogram, but the average what we see from the practical point of view, the average starts from 20 kilo per hectare. So yeah, also this product causes some additional impact on immune system of plants and as a stress anti-stress product.
We can move on.
Yes. So we tested our product on in different way of application. Mainly you can see on the screen is a foliar application on this table. So the crops we tested it was rapeseed, winter wheat, potato, corn, and sunflower as the most tested one. So when you can see by foliar application what we have when we talking about the increase to the yield. So we see in most cases we see more or less stable increase by only foliar application. So depending of the rate, of course. Also, we have tested the product in other way is for seed treatment and pre-sowing cultivation. Here we see as well the product act very efficient with a crop like potato, winter wheat, and on some vegetables, and even so it shows its universal activity and efficiency in case of different crop type. So
just a moment, I want to ask, I have seen our partner from Czech Republic is here, so if you will, you can comment this trial.
Hello, everybody.
yeah, hello.
My name is
Ludek,
Ludek,
nice to see you.
and I'm very pleased that Dmitry has installed his slide into the presentation, because the company we are working for already 3 years on opportunities how to and where to reduce the overall input of mineral fertilizers on soil. Because when we have a look at the overall statistics what's going on here in Central Europe, it was tremendous continuous growth of use of mineral fertilizers, and without or with a very little or negligible impact on yield. So it was just straight comparison, more and more mineral fertilizers, less or lower impact on the yield, and higher impact on the degradation of the soil surface. So we are focused on different projects, what we can do and how we can do. And we met beginning of last year. We met with Dmitry in Czech and somewhere in Central Bohemia, and established trials with the help of research institute, which is based in Prague, one of the leading one on their field station in the small city called Humpolec. And simply we wanted to test what would be the impact if we simply reduce the standard urea rate from 200 kilo per hectare plus amorphos. And if we replace this standard fertilization by something new with some innovation. And what was interesting that we designed it, it was just trials has been running for application standard methods for the evaluation. But so we have already parcels with a low rate of urea which has been applied, and what we have seen that there was very strong correlation with split application of azoto on the leaves. You see it on the right-hand corner down in this box plot chart. There was statistically validated 95% confidence level that there was a good impact on the yield. And in addition, we measure content of NH4 in the soil, which is, let's say, coming from this on the picture. And again, there was a higher concentration of NH4 in milligram per kilo of soil. And what is important to say, there was no application of manure on this particular field more than 15 years. And there was only mineralization of the roots and parts of the plants in the field. But all of the increase of NH4 has to come coming out of these trials, has to come through the application of the azoto help. So it was great information, great support in our decision taking. We should focus further and develop our business direction alongside also with the bacterial products which convert air nitrogen into NH4 in this particular case. What was also, but I didn't realize it from the beginning, but someone else reminded me that, let's say, if you have a look at the core in the standard and in the variant number 9, you see the simply change different color. So it shows that the product also may prolong the vegetation, which is good in corn. It depends on the maturity, etc. But so it proved the effect of the good nutrition and better nutrition of the plants versus the standard. So this is really interesting to see. Of course, this year we would like to see more results from real farm operations. There's a lot of question around application, how it should be applied on the leaves. So we are also investigating new methods, how to apply. So among those new possible application methods is also are considered drones, because it's drones produce bigger drops which just fall down on the leaves and roll out from the leaves down on the soil. So all of this could have a good impact. And so we are really curious on the next development of azoto help this year.
Yeah.
So Dmitro, is it okay or more?
Yeah, super. It's super okay. Thank you so much for your comments, for your let's say initiative somewhere in these trials, and for professional approach to it. And also must say that it's quite critical. I mean, critical conditions, critical circumstances for testing of azotobacter, of azoto help, because usually we are quite, if we recommend decrease of fertilizers to farmer, we don't go to such big difference. Maybe we can recommend 50 kilo of urea, where we have big confidence that we are able to substitute. But here in this trial, we have seen some kind of potential of microorganisms, and I agree that there could be different novel methods of applications. We already have some experience with drones applications of some other bacterial products, but with AzotoHelp it's as well possible. So look forward for new experiences in Czech Republic.
Thank you. Stay in touch. Thank you.
So let's continue. It's not the one test with AzotoHelp. Alexander, will you continue?
Okay. So here we have done an experiment with a few products AzotoHelp in ground.
Sorry.
In Germany on LBK trial station in 2022. So we wanted to see if the different if there is will be a difference with starting fertilizers when we use only our biological products in the control and with the starting fertilizers. And we see that based on the fertilization scheme, we you can see on the screen which and how many fertilizers was used. We can conclude with this trial that AzotoHelp showed a very good result in case of corn yield of corn for silage when we don't use a big amount of starting fertilizers. And in case of ground fix, it's improved efficiency of starting fertilizers and also increased in yielding in comparison to the control variant.
What I want to pay attention to on in this trial, and again, firstly, when I have seen these results, I was a little bit in stress because it's not so typical that you can see here is a variant without starting fertilizer and with. And with fertilizer is worse than without. And that make me nervous because how is that? Fertilizer should add the yield. But after that, we have plenty of trials like that in different regions of Europe, like in UK, Belgium as well, and in some others. So really, technologies are quite intensive in Central Europe, and not always with this intensive technology you reach the maximum. Sometimes you overuse fertilizers, and so with these technologies there is even more space for fertilizers use of the optimization. And you can see that with microbials they work in both very intensive technology and with less intensive, but we will show more of such experience later. And also one important thing, because one of the widely asked question is about correlation of efficiency of bacteria and pH of soil. So it's we always have two approach. One is theory and like knowledge, and second is practice. And we try to find a truth which is usually somewhere in the middle. So it's known that bacteria usually are more efficient in higher pH, neutral and higher, and in lower it's more space for fungi. But still we have plenty of trials with pH starting from 5, 5.5 with bacteria, where we see a significant efficiency. So it's not what's a critical factor if your soil is a bit acidic to use bacteria. So on this, I give back a word to Alexander.
Here we have done a very interesting experiment with AzotoHelp and in urea inhibitor on spring wheat. Before to make this trial, we had an idea that application both biological product and inhibitor of urea is not a good idea because of some potential suppression of product activity. But here we see that you can see the trial scheme when we have a few variants. First one is without nitrogen fertilizer, second with nitrogen, third with nitrogen and urea inhibitor, and two last variants with azote help when we add to the fertilizers and use all three components: fertilizers, inhibitor, and biological product. So if you take a look at the few graphs, like number of grains per year and weight of 100 grains in grams, so you see that in comparison to the simple application of fertilizers with urea inhibitor, adding biological products work efficient, and in case of plant development, especially in forming a bigger number of grains per year and increasing the weight of 1,000 grains. So all of this, and also you can see on other graphs, we have a similar tendency. When we add in the biological product, we have an increase in, in all parts of plant, starting from the plant height, grain yield, straw yield, and finalizing the quality of seeds and number of seeds.
Yeah, so I just want to add that you can see here a second variant with just urea, and with azote help we get plus 400 kilos, and in case of use of urea with inhibitor and then azote help, we also get plus 400 kilos. So more or less here we there was a hypothesis that urea inhibitor is inhibiting bacteria and it's not good to use them together, but from this trial we see that it's quite it's still efficient because even with this inhibition of bacteria, it provides a difference in the yield. Alexander?
Yes. Then we have conducted a few other trials when we use azote help for seed treatment or seed inoculation in Austria on corn seed. Here, particular on slide, and there was no mineral fertilizers used in this experiment, so it's totally organic plantation of corn, and even with this, when we apply the product on seeds, we prove that the product will show an after effect in yield, even without any additional nutrition into the soil, when we add it particularly into the soil. Okay. The next trial was done with on millet in Austria as well. The same methods of application. It was seed inoculation. You see some data about predecessor. It was a green piece, and also you see the total area and the cultivated area of this trial. So what I wanted to mention again, that the application of azote help work actively. So bacteria is active in soil. She is fixing nitrogen and produce some beneficial substances for seeds for better germination, and then we again have a as we can see in the table, we have an increase in yield in totally organic plantation.
So I just want to add, it was like a second crop during one season, so it was it is not so high yield, but still it's organic. I think it's quite a sufficient difference. And also it was a seed application, so the main effect is expected on the root zone. you can see that it's even quite visible, the difference between average plants of on control and trial. And in terms of color, also it's actually, it's I would say, no, there was some visible difference on site because I was on that field. Alexander?
Okay, here on this slide we can see another interesting experiment that was done by our partners when they tested application of azote help on sugar corn or sugar maize when they used sample analysis kit to check the accumulation of nitrogen in corn stem juice. The goal was to determine nutrient difference between trial objects and control variant. So on the trial plot, there was used azote help for 40 milliliters per 250 milliliters of water in furrow. So what we've got in results, we see that in the trial plot we have an increased amount of like nitrate nitrogen on the upper graph, and also we see that application of azote help also cause some kind of second impact on the availability of potassium, and the total result of the experiment proves that the azote help cause how to say, or affect efficient in case of accumulation of nitrogen in plant biomass.
Again, a few words from me. For us, this trial also is interesting because of the method of used here, because it's not so typical for us to measure nutrients in stem of plant. But when we apply products for better nutrition, it's quite logical. So here, after application of azote help, we see the positive tendency in nitrogen content. So it's just another idea for farmers, for partners to how to check products efficiency. So Alexander, does we have any other questions for azote help? Actually, I had some in chat.
Yes.
About the dosages of soil treatment. So I will comment that foliarly, more or less average dosage of azote help is 500 milliliters per hectare. And in this case, the main expectation from product is to stimulate growth of plant because of the metabolites of bacteria. When we apply product into the soil, we expect this direct function of nitrogen fixation here we are studying efficient dosages. Now we are studying from 1 liter to 3 liters. So it's a bit bigger than for foliar application. So what else? About the widespread questions for azote help about the crops. So actually there is no strong limitation because actually most of crops require nitrogen. And if we talk about growing on soil, especially application into the soil, azotobacter will provide nitrogen for different crops. In terms of technologies without soil, it can be applied foliarly for growth stimulation as well. So secondary, about dry formulation. For the moment, we mainly work with liquid formulation, SC, suspension concentrate, but we are in process of registration of water-soluble powder. It will be more stable, maybe a bit more convenient to work with, but both formulations has its pros and cons. So we will continue to work with both. Next question, does bacteria fix nitrogen on leaf surface? Actually, in our basic understanding, azotobacter, which is a free-living soil bacteria, is fixed nitrogen when it is in the soil. So on the leaves, when we apply it on the leaves, we expect more growth stimulating function, but from practice, from trials in Czech Republic, from trials also in some other states like Belgium, we have seen that foliar application is also efficient to substitute some part of fertilizers. It can be also because of not of nitrogen fixation on the leaves, but because of the compensation of growth, energy of growth by stimulation. I mean, some nitrogen is used for that. So we are still discovering this mode of action, but we see that foliar application is also quite efficient, sometimes even more efficient than soil. So how to see product efficiency? No, as for all products, how to say, use and look. I mean, we monitor trials during the season. We look how plants develop, how root system developed, and of course, finally we look on the yield and on the quality characteristics, quantity of the yield, and then we can make some assessment. Or we told you about some instruments to measure nutrients in plant. It's also possible. So drones application to monitor from the air, NDVI indexes with some applications, everything which you have in your mobile phone or in your pocket, in your laboratory, is sufficient to see. How much nitrogen can bacteria fix in the soil? In average 20 kilos up to 60-70 kilos. We have data already for 25 kilos, for up to 70 kilos in Czech. So more or less we can, we believe to this data from 20 to 60 kilos. Is it necessary to apply a product every year? Yes. We will tell you about some experience with another product which we see works for several seasons. For Azotobacter, we don't have yet such information, but again, to have a maximum effect of nitrogen fixation, of course, you need to sustain sufficient amount of this bacteria in soil. And is it compatible with other bio and chemical products? It is surprisingly for us, but Azotobacter is quite good in terms of mixability with pesticides, with herbicides, with some nitrogen fertilizers, with some fertilizers, with urea, with inhibitors of urea, as we have seen. So it's quite compatible. If you have some doubts, you can write us, and we have some. We have laboratory, and from time to time we receive new requests, so we make compatibility and fix that to special table. Another question: how high rates of nitrogen mineral stop AzotoHelp to produce any results? Again, it's difficult to say, but yes, in terms of this, how to say, science and practice, the more nitrogen is in soil, the more, let's say, lazy is Azotobacter, because it does not need to capture it. It's enough of nitrogen in soil. It's difficult to measure the specific amount of nitrogen in soil or with application, because it depends on the soil type and climate conditions and etc. But at least if you have a very intensive scheme of nitrogen fertilization and good organic matter content and nitrogen in soil, so we recommend to think about optimization of nitrogen fertilizer dosages. Then you can have some economy from fertilizer because you use less, and you have a more perspective for bacteria to provide you additional yield and work efficiently. So if you have any other questions, please write them to the chat. We will answer them a bit later. But still we have one another. What is recommended doses of using AzotoHelp on technical cultures like corn and wheat? So here it also depends on method of application. If you apply into the soil from 1 to 3 liters per hectare. If you apply foliarly, more or less 500 milliliters per hectare. And on the seeds, more or less, it's like between 1.5 liter per ton of seeds. But you can check also the dosages on the website, on the page of the product.
Okay.
So, Alexander, what is next?
The next product is ground fix, the complex soil biofertilizer, which is the function of it focused on pK potassium and phosphorus mobilization in the soil. So this is also, this slide is also the answer for a question from chat. What type of microorganisms in the product? So you can see this is Bacillum polymixa, Bacillus megatherium, Bacillus subtilis, Enterobacter, and a little bit of Azotobacter. Here, all of these make the good combination of microorganisms for this particular function, like pK mobilization. So also products have an effect on in the how to say, efficient use of fertilizers when you apply it together with other bio or chemical or mineral fertilizers. So we can even recommend to reduce the consumption rate of fertilizers up to 30% by simultaneous application with ground fix. Also, the efficient use of already added fertilizers is increased by 1.2, 1.5 times, so which is good for plants, and you will not lose this very important nutrition for which is help you to get a good yield. So the dosage, the application dosages is also varied from the method of application. So, but mainly we focused on the application of product into the soil. So, and also for some spring treatment with urea ammonium nitrate as well. So you can see we have different formulations. We have a liquid one, and then also we're working on a dry formulation, which will be introduced soon.
Yeah. Moment.
Yes. On this slide, we see only experiments and practical field results when we use product under press-sowing tillage for different crops, starting from winter wheat, corn, sunflower, and in all cases, when we apply a product with application rate from 3 to 5 liters into the soil, we have a more or less stable results, depending of course, of soil condition and on the type of crop that we grow in field. Next slide here is we see that also when we use under the main soil tillage the product, also you can see the same crops where we tested. It's sunflower, winter wheat, corn. And also we apply product together with some soil herbicide to make it simple for farmer to do not use some machines once again for additional treatment. So we have a quite good result in increasing to the yield. Also, we have see some after effect for the next season when we apply product like this year. We see the after effect without additional application next year. So you will see some examples in the next slides.
Yeah, I again just want to stress attention that a few years ago we also had a lot of requests from farmers. Can we use that together with herbicides? And from point of view of microbiologists, they were not happy about that way of application because also they see some, how to say that, suppression or some influence from herbicide on microbes. However, some of the farmers don't listen to us and tried this method. After that, we go to research stations and repeat that during few years. And now we are quite confident that application of ground fix with soil herbicide is possible. It's convenient because no separate application. and it has a positive result on the yield.
Here we see another way of product application is when we apply it in furrow and spring fertilization. Again, it was mainly tested for the crops like corn, sunflower, and then winter wheat. You can see the rates of application in the table. So we have different rates depending on the way of application, and also even under these methods, we have a stable increase into the yield in comparison to the control side. And also we how to say, see the effect when we apply together with other fertilizers. So it will not how to say, disturb the plants to uptake nutrients and even increase it and work more efficient. Yes, when we apply it together with the fertilizers in critical phases.
Yeah, so also a few comments from me about urea ammonium nitrate. Again, we had this request from the farmers because it's convenient, it's how to say, basic treatment in their technology on winter wheat. And firstly, we make plenty of tests in lab. We have seen that you can add ground fix in tank mix with urea ammonium nitrate. If you can add some water to dissolve urea ammonium nitrate, make it less toxic, it's even better. But still, even with pure urea ammonium nitrate, you can mix like during few hours in tank mix, bacteria survive and work. So first important thing. Second important thing is that again, from the point of view of microbiologists, from our scientists and from all scientists, these soil bacteria, to provide them best conditions for work, you need to cultivate them to the soil. It's logical to protect them, to provide conditions. However, we got some interesting experience with application with urea ammonium nitrate. There is no any soil operations, and we monitored few trials for a few years after application, and we have seen that when you apply ground fix with urea ammonium nitrate on winter wheat, there is effect on winter wheat and there is effect on the next crop, which means that bacteria, even they are not cultivated into the soil, they can survive, migrate into the soil and be efficient even for the next season. So I don't say that you should not cultivate bacteria into the soil when you can. When you can, it's better. So our aim is to try to provide best conditions for efficiency of microorganisms. It is when the soil is wet, when it is warm, it's better to cultivate in the soil, better to use separately from chemicals. However, from the point of view of practice and experience, we see that some exclusions are possible and are still effective. Alexander?
Yes, here we see the trial which was done in Vinnytsia National and Agricultural University, when we have tested different rates of fertilizers together with ground fix. And we, you can see below on the graph when we applied the product together with a full dosage of NPK, and when we apply the ground fix with a lower, like a minus 30% lower dose of fertilizers, we have more or less the same results in yield. So which is give us a signal that how to say, we can a little bit manipulate or recommend reduction of fertilizers for farmer because the product improves the efficiency of other 30% of it and gives the same effect to the yield.
Yes. So this was a trial a few years ago, and really it gave us a big inspiration for this direction. And we do another trials, which some of which you have already seen, but some of them we will show you, which prove our confidence in this direction. To that with ground fix azoto help you can optimize fertilizers use.
So the next trial was in combination of our another product, EcoStern, for plant residue decomposition and ground fix. We checked the way could this product substitute some amount of fertilizers when we apply it on soya. This is a trial from Serbia from 2020. And based on the trial scheme, we see that in both in control and trial, we have used some potassium chloride fertilizers in a rate of 100 kilograms per hectare. We have used EcoStern 1.5 liter ground fix 5 liter per hectare into the soil, and we also just wanted to see if the additional fertilizers on control side could compete with the application of biological product, and we were surprised as well, because biological products showed even more efficient results than additional fertilizers on control. So which also it's a how to say, another signal for us to able to recommend the product to substitute some amount of fertilizers. In this case, it's 137 kilograms of stable ammonium nitrate. So which economically very efficient for farmers. Yes, very efficient for farmers. And also you can see the development of plants on screen. Here we also have done another experiment with ground fix and azoto help on research trial station at the Institute of Steppe Agriculture in Ukraine in 2022. If you just take a look at the bottom of trial scheme, you will see that we have a different variants where we have a NPK like 60-60-60 and NPK 42 for all elements together. In these variants, we applied simultaneously ground fix and azoto help together, and the way we wanted to see, how to say, the purpose was to see if we can substitute some special amount of fertilizers in case of application of bioproducts. And once again, we have quite good, how to say, or efficient use of fertilizers by using microbial products, and also how to say, efficacy in yield production, or increasing yield in comparison to the control side with a full dosage of fertilizers. So basically, we have reached how to say, our theory when we can prove that we can substitute some amount of fertilizers.
Yeah, actually 30% here was in the scheme.
Yes.
30% different in fertilizer. So cutting a fertilizer by 30%, we even get a little bit more of the yield. So we get economy of the fertilizer, and we get some. So because 50 kilos of sunflower is still something, so it also adds to the economy.
Yes. So here's another experiment when we use ground fix to substitute some fertilizer amount in furrow on sunflower in 2022. We had few variants: control, ground fix with rate 1 liter per hectare applied in the row, and the third variant was the fertilizer diaphan. I think it was 25 liters, 50-20, like NPK, also applied in the row. And how to say, we have proved again, the ability of ground figs to mobilize nutrients in the soil without additional application of fertilizers, and increase to the yield in comparison to the control and to the variant with only mineral fertilizer.
Yeah, I just want to add first thing that we studied this for 2 years, so it's quite sufficient data. Secondly, that the soil was quite poor and with a little bit acidic pH. And the third thing is that in our basic recommendations, usually we don't recommend to substitute in furrow fertilizers because it's quite low dosages anyway. Usually we recommend to use them in combination, which also is quite efficient, and we see it in plenty of trials. Also, it's very good. There are some farmers with novel technologies who have few on the sowing machine. They have few separate applicators. So if you can separate fertilizer and some pesticide and biological product, it's a perfect condition. But still, we have data that during few hours you can mix starting fertilizer with ground figs also. So you can either try. No, it's always a question of technology. We try to help each farmer to make a solution for him. But yeah, you can either substitute or you can make a combination depending on your conditions and aim.
So here is the case practical case when we use ground figs together with soil herbicides for the sunflower in 2022. It was also done at research station at trial plot. And you can see that the humus content is quite high here on in tested area and control site as well. So here we hope to see. We see the purpose was to see if the combination of microbial product together with the herbicide will be more efficient, as we know that it is difficult to make two treatments, two for their application at the same time, so it's costly. And in our testing variants, we proved the ability to combine biologicals with the chemical product and also increase it to the yield, so get some additional yield. Yeah. Here we also see two different trials on sunflower when we tested the ground figs in different methods of application. When we had variant in first case to only ground figs for pre-sowing cultivation and ground figs with a soil herbicide. We have got positive results in the combination of both variants in comparison to the control. On the second trial, we also see that products were applied in pre-sowing cultivation with a soil herbicide in another method, like in a row with a lower dosage of microbial product. And when we combine ground figs with azote help, when we apply it to the row. So in all variants, we see additional income, additional increase to the yield, again, in comparison to the control. And also it's important point to see that these trials were done on different soil types. So it's quite a good point to say that the product is a bit universal in case of conditions to use.
Yeah, also I want to pay attention. It's interesting for us as well to find out that use with soil herbicides sometimes can be even more efficient than pre-sowing cultivation. We think it can be caused by some kind of decrease of toxic effect of herbicides on the crops. So yeah, it's another method of application which is quite convenient, and you can see already that we have a big plenty of studies that confirm that it's efficient. So I will give a brief comment on this few slides. So besides monitoring of the yield, we also pay attention to the soil. So we do some complex soil analysis where we monitor different indicators. So in this case, we took soil samples before application of ground fix and a few months after. So what we can see is that actually in both phosphorus and potassium, we have some positive influence, more or less like from 20, 30, 40%, which can explain us that mode of action, that results which we have in fields. Besides that, we monitor effect of our products on soil microbiome, consortium of bacteria and fungi. So, for example, after of application of ground fix, we see that amount of bacteria increased, in terms of pathogens, we see that we have a positive influence on fungi biodiversity, because adding some competition into the soil in terms of pathogens, we give more space for saprotrophs to develop. And as well, we look on some bacterial indicators like amount of azotobacter, nitrogen fixing bacteria, and some other groups. So we do that in some not only on like research stations but in field. So it's not so, it's quite widespread that we see such a positive increase of pK in the soil when we use ground fix, even when we use it without incorporation, like here it was used during vegetation of corn. So what about questions, Alexander?
I think we already answered to the question from chat. It was based on Azot help, but here we already answered to the first question, actually, how much fertilizers can be saved. So you have seen some practical cases, some trial schemes when we answer to the question of how much fertilizers, which kind of fertilizers, and so we can also, it's based on your fertilization scheme always, and some soil analysis. But yes, we could prove that it is possible to reduce up to 30% of NPK. For the next question, does ground fix work equally well on different type of soil? From our practical experience, we showed. You also have seen it from the previous slides when we mentioned different type of soil in almost all experiments, and mainly that was different soils. So my answer is yes, the ground fix can be efficient on different type of soils, but it also depends of the soil enrichment. Poor, rich soil, depending of some, chemical characteristics between the compounds inside.
Alexander, we have one question in the chat. It's have we checked P content in leaves after ground fix application? So this method of use, like leaf stem analysis, is kind of novel for us. So we continue studies with it. So for the moment, no, but I think we will study during this or next season. So about the application with fertilizers, so you have seen some examples with urea ammonium nitrate, with also with starting fertilizer. So we have plenty of trials. So of course, it's better to check in each case if it is possible with that, but normally, if it is a liquid fertilizer, you can mix it for a few hours during spraying. If it is actually, we have even some experience with granular fertilizers when they are sprayed with bacteria, like more or less 2-5 liters per ton, and it also improves efficiency of them. About the application every year, here we see that as ground figs have prolonged effect for a few seasons. So the most economic way is to apply once per 2 seasons, but the most, if you want maximum yield, it's better to apply each year, then it's will provide you highest effect. When it's better to apply fall or spring, both ways are possible, but we recommend better to apply before sowing cultivation, so that there is some time to split nutrients, but still there is a maximum concentration of bacteria during vegetation in soil to provide that work. And about the incorporation into the soil, it's not necessary, but it is recommended. It's always better to provide optimal conditions for bacteria, but from some cases you can see that from urea, ammonium nitrate, from use with herbicides, application even without incorporation is efficient. So if any other questions, please write them to the chat, and we will continue to our last star of this day. Alex?
Yes, the last product today we will consider is the microfriend. It's a complex mycorrhizal product which is based on some fungi, glomus and trichoderma, which can have an ability to create a symbiosis with the root system. And also in product includes some number of bacteria which help to provide better conditions for gifts to grow and to give some additional how to say, the bacteria produce some additional substances which helps seeds to germinate better and provide some additional nutrition for plants later. You see also the rate of application is differ. It also depends for the methods of application for pre-sowing seed treatment or application of the product into the row. The product has I would say quite long shelf life, and good titer is 1.5 up to 100 billion colony forming units per milliliter of product. We have tested microfriend on different crops, like let's say group of crops, cereals, which include some spring wheat, winter wheat, for corn, for sunflower, other technical crops. Also, we have tested the microfriend on some legumes, and based on all categories, we have exceeded the rate of efficiency more than 87%, especially in particular case when we apply a product on seeds and corn. And in all, we have also more or less stable income and increase into the yield for all categories of crops.
Yeah, just again would repeat that use of microfriend is quite efficient because of quite low rate per hectare, because you apply it on seeds, especially on corn and sunflower, but in average you get more than 100 euro of extra yield, which is very sufficient and economic efficient tool to increase the yield.
Yes, here we see one of the practical cases of seed treatment with microfriend and winter wheat. It was done in 2022 in Ukraine. This is data from 2 years, from 2021 and 2022. We see the different backgrounds of fertilizers for variants. The first variant was without NPK. When we use microfriend, in comparison to the control. The second variant, when we use a NPK like 90, 60, 60, also with the same variance control and the microfriend application. And when we use organomineral fertilizers with a bit lower dose of like NPK like 60, 30, 30 with same variants. And in each variant, starting from no NPK up to the last one, we see that the microbial product increase the area and help plants to uptake more nutrients. And we see the expected results, additional yield increase. So another test was done on the sunflower with a seed treatment together with microfriend. We have the same fertilization background for variants, and we also see that depending of maybe crop type or soil conditions, in some cases microfriend have a good, bigger result. In some case, a bit lower, but still we have positive effect of application of seed inoculation with a mycorrhiza. And the last test on this trial station was done on buckwheat with a microfriend. The same fertilization scheme for it's a bit different scheme, but because we have without fertilizers, some variants with a mineral, or I guess it's a some technical mistake.
I think it's the same here. In both cases it was 20, 20, 20, I think.
Yeah, but we can say that this rate is a bit lower from the sunflower test and another crop. So maybe because of the biological biology of the plant growing on field. So maybe potentially the buckwheat will not recommend higher dosage of fertilizers to produce for production of raw material. So we but anyway, we have positive after effect of product application in almost all cases, even without fertilizers used.
So I will add just a comment that from this trial we see one thing, that potential of biologicals of mycorrhiza on the seeds is discovered when there is more space for yield improve, and mainly it is more economic efficient than just to use maximum rates of fertilizers. However, when there is the yield of crop is close to its potential, it's more difficult to provide bigger difference, but still we get, even in most intensive schemes, the additional yield. And Alexander, what about this trial?
This trial was done in Germany, I think in 2021, when we have designed a special scheme for the trial together with the microfriend and other products. The purpose was to see if we can reduce, if we can reach the high yield in reduction of NPK up to 20%. And from the table we see that you also, I think, Dmitry, you will mention the full dose of application. Yes, in case of economic point of view. So when we see that when we apply full dose of fertilizers on the field for potato crop, we even reduce the yield and level of starch per hectare. In comparison, when we use the 80% of mineral fertilizers. And when we add some biological products together, it's a ground fix, azote help, and microfriend. We increase it. We not only increase in case of yield production, but also in the quality of raw material at the end. Because that plantation was this production was based on this starch amount at the end. So we have a good economic efficiency in case of reduction of mineral fertilizers and biological use.
Yeah, as far as I remember, starch price in Germany is like more than 300 euros. So economic effect is positive, but also when we received these results, we were a little bit scary because how is that again? That with less fertilizer, it's better yield than in control. But now when we get such trials in different parts of Europe, and we see that it's not so untypical, that indeed schemes are very intensive, so sometimes they are even toxic for plants, so some decrease of fertilizer itself can be positive in the scheme.
We have a few. I guess we have a few practical cases left before the popular question asked about microfriend. So here we see another trial on microfriend in Ukraine. Microfriend was used for in furrow together with a liquid complex fertilizers with amount 40 kilo per hectare. Trial was done on winter wheat. We can see some picture from the satellite. We see the clear difference between variants when we have just a control, when we have a microfriend with a liquid complex fertilizers and biological rate of application is 0.3 liter per hectare, and with increased dosage 0.4 liter per hectare of microfriend together with the fertilizers used. And we see the tendency in case of plant growth stimulation on picture between variants and control, and we see the difference in color from satellite pictures, and we see the surprised increase in to the yield when we apply microbial products on winter wheat. Yes, and another trial, we have tested a mycorrhizal product with rate 0.7 liter per hectare in Germany at LBK trial station on potato. Yes, and in this case, we see also difference in starch amount. So the product was or even improve some quality of raw material and the amount of how to explain, some amount quality of product at the end, and also we see additional increase to the yield. So again, product not only focus, or how to say, we see it from the view of additional yield, but also from the improvement of raw material at the end.
Yeah. So maybe I will give you comments. With microfriend, we have two formulations, liquid and dry. So we frequently receive questions how to apply them. So in case of liquid form, you can use some special equipment for seed treatment. You can use liquid fertilizers, liquid microbial fertilizers in furrow urine application. Yeah, and sometimes, of course, farmers use some what they have at home. I mean, even concrete mixers is available, applicable in some cases, but yes, so there are different ways. And in case of dry formulation, it's treated on some kind of sorbent. It can be peat or it can be Kieselguhr, which we are registration in Germany now. So You just add this material to the tank with seeds, mix it with your hand or with some special tool, and that's it. This method provides minimum time out of the packaging and outside of the soil, so it's very friendly for microbes, and you don't activate fungicides in case seeds are pre-treated with them. It's very often the case. So this formulation we see quite convenient. Of course, you need to not to forget to add it before sowing, but yeah, it's worth it. So what other questions we have about the crops to use MicoFriend? For most crops it works. There are some group like rapeseed. Alexander, how this group is called? Do you remember? Where we cannot use. In Ukrainian, it's хрестоцвітні. In English.
Give me a second. We can go to another question. I will.
Yeah. Also, but the main thing is that if you mentioned MicoFriend is has a complex composition, and of course mycorrhiza is not forming with some of the plants, but with other microbes in composition like Streptomyces, like Bacillus, Lactobacillus, you have effect even in the case of some crops who does not form mycorrhiza. For example, when we just start to work with this product, we have plenty of trials, maybe up to 10, with rapeseed, which does not form mycorrhiza, but with sufficient difference in the yield. So about the preparation forms, we just showed you about liquid and powder. Again, crops which does not form mycorrhiza. Alexander have written to the chat that with brassicas, mycorrhiza is not formed, but even again, because of the complex composition, you can have some effect from MicoFriend, not from mycorrhiza strains. How to see mycorrhiza? Not an easy thing. You will not see it directly in the field. Usually it can be done only in some professional laboratories under microscope, but actually do you need to see that? Only like I don't know, curiosity, but because main target is yield, quality of yield, that are the things we monitor mainly. How long does mycorrhiza last in the soil? So it usually have symbiosis with host plant, and while it's alive, they are alive together. But so in intensive technologies in field crops, usually you have one season crops, and because of that, answering the next question, we recommend to treat the seeds with mycorrhizal products each year to have maximum efficiency. Of course, if it is some gardens and you make mycorrhization in the beginning, maybe you can have less applications, but still we recommend to keep mycorrhiza amount sufficient in the root zone to apply it each year. And talking about the seed protectants, when we talk about dry formulation, there is minimum risk. When we talk about liquid formulation, there are some less toxic fungicides, like, as I remember, Maxim, and there are some more toxic, which does not allow fungi normally function because it's fungicide. So it depends on the fungicide. You can always ask us the opinion to our on email, on chats, to our partners, and we will give you the latest information about your protectant. And of course, very friendly method of application is in furrow, because then you apply mycorrhiza, you settle mycorrhiza in the rhizosphere, in the root zone, no direct contact with fungicide, and it also is efficient to keep mycorrhiza alive. So does anybody else have any questions? Because we are on the say close to the finish. And yeah, while you are thinking, I will say that it's a big pleasure because it's the first webinar of this year, and we will monitor the frequently asked questions, up-to-date topics, and keep you updated on the novel biotechnological solutions, about the most interesting, intriguing results, especially with fertilizers optimization, about carbon sequestration, about soil enrichment, about different tools of healthy soil. Yeah, so we asked for the presentation. So first of all, recording of the presentation is online on Facebook page of BTU Center. Also, we will put it online to YouTube. So please subscribe to our accounts on Facebook, LinkedIn, YouTube. You will always find interesting materials there. And about the presentations, please write us a request, and of course we will share it with you. Yeah, so on this, again, thanks to all for joining us today. I hope that this information was interesting for you. I wish you to have the same or better results in your own trials, in your own practice, and don't be afraid to work with biologicals. There is a huge already experience with us, with other companies, for their usage, the efficient, ecological, and economical. So see you soon, personally or online. Have a nice end of the week. Bye-bye.
Thank you so much. Thank you for joining us.